Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors in R3. So as per the problem, given vector x equals 1, 4, negative 1, vector y equals 1, 3, negative 2, and vector z equals negative 2, 1, 0, determine a vector equivalent to each of the following. So let's start with part A. So we should sub in the vectors for x, y and z in this expression. Now we have to do the scalar multiplication. So we should multiply the vector y by 2. So 2 times 1 is 2, 2 times 3 is 6, and 2 times negative 2 is negative 4. Now we can subtract the first two vectors. So we have to subtract their x, y and z components. So let's start with the x component. So 1 minus 2 is negative 1. 4 minus 6 is negative 2. And then minus 1 minus negative 4 is equal to positive 3. Now we can subtract these two vectors. So negative 1 minus negative 2 is equivalent to negative 1 plus 2, which is equal to 1. Now we can subtract the y component. Negative 2 minus 1 is equal to negative 3. And 3 minus 0 is equal to 3. So this should be the final answer for part A. Now we can analyze part B. So in part B, we have to find the vector equivalent for negative 2x minus 3y plus z. So we'll sub in the vectors x, y and z. Now we can do the scalar multiplication. We'll multiply the first vector by negative 2 and the second vector by 3. Now we can subtract the first two vectors. So we have to subtract the x and the y components and the z components. So negative 2 minus 3 is negative 5. Negative 8 minus 9 is negative 17. And 2 minus negative 6 is equivalent to 2 plus 6, which is equal to 8. Now we can add these two vectors. So for that, we'll just add their x, y, and z components. So negative 5 plus negative 2 is negative 7. Negative 17 plus 1 is negative 16. And 8 plus 0 is 8. So this should be the final answer for part B. Now we can analyze part C. So we'll sub in the x, y, and z vectors in the expression in part C. Now we can do the scalar multiplication. So we'll multiply the first vector by half. So we multiply each component by half. And we can multiply the z vector by 3. So we multiply each component in that vector by 3. Now we can subtract the first two vectors. So we'll subtract the x, y, and z components. So let's start with the x components. So half minus 1 is negative half. 2 minus 3 is negative 1. And negative half minus negative 2 is equivalent to negative half plus 2, which is equal to positive 3 over 2. Now we can add these two vectors, and for that we should add their x, y, and z components. So negative half plus negative 6 is equal to negative 6.5 or negative 13 over 2. Negative 1 plus 3 is equal to 2, and 3 over 2 plus 0 is equal to 3 over 2. So this should be the final answer for part C. Now we can analyze part D. So we'll sub in the x, y, and z vectors in the expression. Now we can do the scalar multiplication. So we'll multiply vector x by 3. We'll multiply vector y by 5. And we'll multiply vector z by 3. Now we can add the first two vectors. So we'll add their x, y, and z components. So for x components, we'll add 3 and 5. Next, we'll add the y components. Next, we'll add the z components. Now we can add these two vectors. So this should be the final answer for part D. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.